Hello everyone, in this video I'm going to discuss the topic limits and continuity. Here are the example for the continuity. So before we further our discussion, I'm going to define the modulus of x minus 3. So given the definition, modulus of x minus 3 is equals to x minus 3 and the domain will be x minus 3 greater equals to 0. Next we will have negative x minus 3 and the domain will be x minus 3 less than 0. So after we simplify the situation, we will have modulus of x minus 3 is equals to x minus 3 and the domain will be x greater equals to 3, followed by negative x minus 3 and the domain will be x less than 3. Next, I'm going to illustrate the situation, into a number line. So now I'm going to locate the value 3 and 4. So let's begin with the first function, x squared plus x minus 12 over absolute value of x minus 3, where we have x less than 3. So based on the domain, we notice that negative bracket x minus 3 would be the function that is suitable for this domain, which is x less than 3. So now we have x squared plus x minus 12 over negative x minus 3. If x is equal to 3, so the function would be a. So followed by from 3 to 4, where 3 is not included, the function would be 2x minus b. Finally, x greater than 4, the function would be c. So now I'm going to discuss the question A. Find the limit when x approaching 3 from the left and the limit when x approaching 3 from the right. So limit when x approaching 3 from the left, the function would be x squared plus x minus 12 over negative x minus 3. If we substitute the value, we will have 9 plus 3 minus 12, and we will obtain 0 over 0, where this is what we call the indeterminate form. So there are several strategies that we can use to solve this kind of situation. Number 1, multiply by the conjugate. Number 2, factorize the situation. So for this case, I'm going to use the factorizing situation. So after we factor the situation, we will have x, when x approaching 3 from the left, we will have x plus 4 bracket x minus 3 over negative x minus 3. Notice that we have a common x minus 3. So we can simplify the situation. So where we will have limits when x approaching 3 from the left, we will have negative x plus 4. So we will have negative 7 when x approaching 3 from the left. Limits when x approaching 3 from the right, the function would be 2x minus b. So the answer would be 6 minus b when x approaching 3 from the right. Now we are going to discuss b. Use the definition of the continuity to determine the value of a and b if f is continuous at x is equals to 3. So meaning that limits when x approaching 3 from the left for the function fx is equals to limits when x approaching 3 from the right for the function fx. So by referring to the left hand side, limit when x approaching 3 from the left, the answer will be equals to negative 7. If limit when x approaching 3 from the right, the function will be 6 minus b. Rearrange the situation, b is equals to 13. So now we are going to find the value a. So as we all know, limits when x approaching 3 for the function fx, the answer will be equals to approaching negative 7. So based on the b, use the definition. So based on the definition, the condition number 1, f3 will be equals to a. 3 will be equals to a. Condition 2, limits when x approaching 3 for the function fx, the answer will be equals to negative 7. So condition 3, in order for the f to be continuous, so limits when x approaching 3 for the function fx will be equals to f3. So by using this definition, negative 7 will be equals to a. So for b, the answer will be equals to 13, and a, the answer will be equals to negative 7. So now we are going to discuss c. For what value of c is f discontinuous at x equals to 4? By using the condition number 1, f4 will be equals to, if it's a 4, we are going to use the function 2x minus 13. So we will have 2 bracket 4 minus 13. So the answer would be 8 minus 13, we have negative 5 for the function f4. So f4 is equals to negative 5, define. Second condition, limits when x approaching 4 from the left. The function will be 2x minus 13. So we will have negative 5 as well for the value when x approaching 4 from the left. Limits when x approaching 4 from the right. The function would be c. So the answer will be equals to c. So in order to make the f is discontinuous at x equals to 4, the condition for number 2 would not be exist. So meaning that limits when x approaching 4 from the left, function fx, is not equals to limit when x approaching 4 from the right, function fx. So meaning that from here, the value of c cannot be equals to negative 5. So that will be the answer. If the value of c is negative 5, so the f is discontinuous at x equals to 4. So in order to answer the question c, for what value, the value will be c is equals to negative 5. So that f is discontinuous at x equals to 4. So here we are, and thanks for watching.